Alright, we're on to our next project here. So we got a set of cylinders here that we need to bore. These appear to be shovel head. Let's see, thick flange, so that means they're 80 inch or at least 78 and later. You don't know what size they are until you measure them, then you know what it is. 7480s had the same casting they're made from. The only difference was the actual bore. So externally, you can't tell the difference. Internally, you measure the bore and that tells you which one you got. So you take your calipers and you measure it. Okay, this one appears to be under 3.5 inches, so that means it's a 74-inch motor. So this is about 3.480 on this cylinder. Looks like we're about 78, 79 thousandths down here where it doesn't wear. Okay, this one over here appears to be about the same. Imagine that. Okay, so you can bore these things to 40 over 80. That's 60 over 74 plus 40 is 100 over. You can bore 100 over on the 74 and still be within bore spec on these. Even though Harley said you can only go to 70, that's only 10 over 80. So in the real world, you can bore them 100 over. Now 74-inch cylinders, the early ones, you can't. You only go 70. So you have to know which cylinders you have. The early ones have a 66 part number on the side instead of a 78 part number. So you guys have a 78 number in there. Hard to read, but probably aftermarket as well. It's hard to read. This one's a lot better. You can read it better. So plus these are thicker flanges. The 74s are only about that thick. A lot thinner. Alright, so the problem with the cylinder is it lost the wrist pin and chewed up everything. So now you have to clean it up. And answer the phone too. Always got interruptions around here. Hello. Hello. Alright, I don't know why I shut the camera off. Nobody was on the phone. They just wanted to ring and bother me. So if you're the guy that did that, it pisses me off. Quit doing it. Interrupts my videos. Okay, we got to bore. We got to figure out what the what actual size and stuff is. So we need some mics in here. So this is your 3 to 4 mic. This is your 2 to 3 mic. And this is your big boy mic, 4 to 5. This is your inside mic, which fits in this hole over here. I broke my mic. There's a screw in here I can't get out no more. So I can't change out the pedal stool in here anymore. So I can only go down to 80-inch bore. And evidently go 20 under. Wherever my line is at. Can't even see the line because I'm too far down. There's your line right there. So that is 3.5 inch. I can go 5, 10, 15, 20, 5, 30, almost 28 under. That's why I can put that in there because it's only 20 under. So I can cheat and use this mic. At some point I'm going to figure out how to get a screw in this thing. First you got to get the screw out you can't even see. Then you got to buy a screw where you don't know what you need. Or you just want to use this for 3 to 3.5 inch bores. You don't have to worry about it. It's basically only an 80-inch bore mic for fits Evos and shovelheads. If I need a different size mic, I use the old stuff here, which works really good too. This is from the 50s and 60s. It always works. I get all kinds of sizes for that one. That was dad mics. These are my mics. Okay, so we got to figure out how deep this is worn. So I don't know if you can see in there what that is in there, but it's in there. And from this side here, usually they wear more on the top and the bottom than they do in the middle. What happens is the wrist pin as it comes across, the wrist pin is round, so it hits right there and just puts 2 big gouges in it, and then eventually puts a big pocket on each end. This cylinder here does not have the pocket. You can see the wear mark in there though. The pocket is from debris. and bouncing around in the hole. So the debris is the iron melting away off the cylinder from the steel wrist pin rubbing on it hardly. Hard, not hardly, but hard. Okay, so this has very light grooving in it. And this mic won't go down, it's very small. But it should go down enough to get into there. There we go. Problem is the groove is not as wide as the mic, so you only hit on the outside of the groove. Okay, so well, we don't have a number to go by. I'm going to go 20s over here. That was only a 2 thou difference, so you can't tell anything. So we're going to do, we're going to bore the cylinder. Now you got two ways of doing this. You can bore it on center, take it out equally until it cleans, or you can cheat and put the boring bar more toward this side because there's no wear on this side. See, this side over here is good. So you can cheat and move that thing over 5 thousandths, which is equivalent to the 10 over bore, and cut 5 extra on this side and then clean it around. And that allows you to run the bore 10 thou less than what it would have normally have been. So I do that a lot. I don't like doing that more than about 20 thou though, you know, if you got a standard bore to work with, because it does make it thin on the one side. But it does save the cylinder so you can bore it multiple times after, not using it all up on the first go. Now after you get this one cleaned up, we'll come back and bore this one out and match it. You don't have to do that, but the customer wanted to match it. Me, I mismatch them, I don't care. My race bike, I ran 20 and 40 forever, and then I went to 20 by 50 because the cylinder got worse. And big deal, didn't make any difference. That was on a fuel motor, race motor, I don't care. So no reason to play with things too much you don't want to. So we have a 60 over piston here. We have another 60 over piston. And we have a 50 over piston. So I guess we're going to try the 50 and see if it works. And if that don't work, we're going to go to 60 over. And then we'll bore this one to match. So the first thing I do is measure the piston, see what you got. First I'm going to measure the cylinder, which should already be set more or less. Okay, this is our actual bore. So you set the mic to what the cylinder is. You don't have to read anything, just know where you're at. Okay, this one's on 1.5 on the mic. Now you take the piston you got to use. How far do you have to go? There's 5, there's 10, there's 15. Okay, not 15. Come back about 3 of that. So you only got 12 thousandths to work with this one. That's going to be rough to do. Like, I don't think it's going to happen. Okay, now we got to figure out what size the mic is actually set at, and it looks like we're at 92, 492. That's the piston size. Now these pistons are 74-inch pistons. You only run them at 1 3/4 thou. 80-inch pistons you run at 2 thousandths. This is kind of in between. You know, so you can do either one. It doesn't really matter. You know, how hard you're going to ride the bike. If you're going to drive the piss out of it, put it at 2. You're going to drive normal, put it at 1 3/4. Not 1.5, 1 3/4. Or you go in between. It really doesn't matter. Now, if you're really going to go hard, then you make it, 3 or 4 thou. So 1 3/4, 2 is your stock number. You want to leave about 3 thou, or at least 3 to 4 for honing, minimum 3. So that's 2. We back up to 10. So we're going to be anything higher than 10 on our mic, which is 90. So that'll be 89 on my bore mic over there. Give yourself another thou extra just in case it doesn't bore on size. And that's what we're going to do this at. So we're going to go with a 5. We got 10 thou to work with here basically, which ain't much. So I'm going to use my feeler gauge. I'm going to cheat at 5 thousandths. Right there, 5 thousandths, see the number? And that's how we're going to set this thing up. Very, very unlikely we're going to clean with this piston. I ain't holding my breath. That feels a lot deeper than 10 thou anyway. But you never know. I've had ones that felt really, really deep and they cleaned at 20. So You thought they were 50 thou deep, so you don't really know. Okay, we're going to use our kwik-way boring bar over here. So, right there, we got Dad's flying skeleton head over there. Top secret, nobody's supposed to know what that is. It's got a flathead motor on it, so you know how old the sticker is. Or decal, that's a decal, not a sticker. Stickers stick on, decals don't. Decals stick on differently. Alright, first you gotta do is clear a pathway because someone's got a bunch of crap on the floor. I don't know how that happened. That goes back over there to catch the chips. Evidently somebody's been not keeping up on the housekeeping around here. So there's a big mess everywhere. I don't know how that would have happened around here. Obviously somebody doesn't care about their equipment. So there's your bore mic. Obviously we keep good care of it. There's your cutter. Keep good care of that one too. There's our brush. That cleans the orifice hole up in the boring head. These are our splocks to put the cylinder below. You notice they're chrome plated. Dad liked chrome plated everything. It's his boring bar. At least it used to be. Alright. Clean as a whistle. Kind of. Appears to have a good layer of crap all over the bed. A little can of brake clean. Doesn't hurt to clean it every now and then just for the hell of it. Nice thick layer of goo on it. I don't know if you can see the goo layer. See, there's clean. There's dirty. One layer wasn't enough. Come back and hit it again. Yep. You know, so that stains the paint over here though. Be careful about that original paint. This has got some good junk built up on here. Have to actually take a scrub pad to it. The chucking surfaces are here and along here, that's what matters. The rest of it doesn't really matter, it's cosmetic. Alright, it roughens it in a little bit. Table below is nice and dirty too. Oh yeah, got the same build-up. There's a shocker, huh? Got a lot of lung buildup on it. Oh well, that happens when you don't take care of your stuff. And you haven't used it in a while. It does too. Okay. Now that's held on with one T-bolt underneath it. And this loosens it up so you can move the boring bar around, center it. Wipe the tools off. Probably should put some anti-rust down before I go too far. See, first you clean it, then you CRC it. Protects it. Probably a lot of that buildup is CRC. take a scrub pad and bring it all back to steel if you want, but yeah, we'll get too carried away doing this job. You don't want to make people too happy on you online. Okay, I'm going to move it over here. Clean off the excess area that was already not clean. You want to make sure you have a nice, good, clean surface to work to, so everything pulls in flat, square, and true like you want it to be. That is kind of important. All right. Wipe everything off. The underneath is actually more important than top, because underneath is what you center off of, not the top. Top is for the boring bar to slide on. Underneath is for the cylinder to go in. There's a bunch of chips down here now. Get it out of the way. Wipe it off again. Alright, get our blocks cleaned up. You can see how nobody's ever missed mine, screwed up and hit the block, see? That would never happen around here. Never ever. Been hit there, been hit there, been hit there, been hit there. Ah, I hit on all four sides. Yeah, that's good. Equal opportunity. Okay. Wipe down all the tools here. Okay, now what this does, it goes inside the machine. There's 3 fingers that go in here that center the cylinder up right there. And this will set the depth of how far they go out. It's a micrometer head. So when you buy these boring bars online, you never get the stuff you need to actually use it, which is this. This is actually worth more than that, because that's worthless without this. Remember that when you buy tooling. Don't buy just a machine. Get the tools that are with the machine. They will be the cheapest when you buy the machine. Because more than likely, whoever's selling don't know a thing about what they're doing. So they'll give you this thing for like $2 or $5. You got to replace it. If you can even buy it, it's probably $200. Okay, so now everything's all cleaned up again. We're ready to start working. There's a hole right over here you clean. Right there. Show all the lint off the brush from the rag I just put on there. So if that's got chips in there, then this doesn't hit here correctly on the taper and inside the ball socket. The ball is what centers this, and the taper over here is what you adjust for setting the fingers. That's how that works. Okay, we go back over to our cylinders, and we got to do the same basic thing over here. We got to clean these up too a little bit. Pretty straightforward. Make sure the gasket surface is clean. Use my good carbide scraper, my new one. So you get all the junk off the flange here. So you see what comes off is a little fungi. That's what you want off of there. Side here looks fairly good. They look like rust. It's actually red sealer of some type. You can hear it as I go across it. I almost dropped it. Alright, after you get that clean, then you hit a file on there. Use a doll file so you don't screw up the surface. Make sure there's no burrs. Now you don't center off the head, you center off the base. The base is more important. But I always clean all the surfaces. This is the one that matters. See that high spot there? Okay, now you gotta put the cylinder in where you can see the bad spot. You gotta see if it's gonna clean. So I'm going to put in the boring bar so I can see the bad spot, which is here. And we need our offset feeler gauge to actually do the job. Okay. So what's going to happen here is the blocks are going to hit on the gasket surface here, 180 plates across. This is going to push up into the bottom of the table over the hole right there. And then the machine's going to go down inside of it, and the 3 fingers are going to pop out to center it. And I'm going to put the feeler gauge into one of the fingers so it offsets it over. That's how all this works. Okay, where's the bad spot? How loose is the bore? This thing has a very loose bore on it because it's made for a big cylinder, so we have to fix that problem. So the way we fix that is we take our torque plates that we don't use for torquing. We use these for boring. This is your adapter plate. It has the same bore as a small cylinder because I have 2 different sizes of these. And then the outside covers the whole hole up there, which allows you to center up a lot better so you don't have a tilt angle like that in there. So this goes on here like this. You know, it fits on there nice and cleanly. You want to make sure it's nice and flat, no jiggle. If it rocks a little bit, you got a problem. Put that back on there. Now we can jack this thing all the way up. There's a bottle jack down here in the bottom that you just pump up. Now it's very important that you have the bottle jack under the hole centered. If it's your offset one way or the other, it'll cock it. So you got to make sure you keep it halfway close. We have a cheat line down here, so I know where it's at. Right there. Still want to center the cylinder over the hole. Bring it up, rotate a little bit with a little light pressure. Make sure everything's nice and clean. And then you put some pressure to it. Now if you put too much you break it. If you don't put enough it comes loose and screws it all up. So you have to kind of know how much pressure to use. That's done by feel. Okay, so now get this thing over here where it belongs. Next thing is what fingers are in it. So to figure that out, we have to go up over here. Yeah, up over here. Use camera. Remember I told you about those tools you need? See that name right there? It has things like this that you need. See, it's got numbers. These are bore sizes and what finger number you need. So we're at 480 right now. So we're either at the top of number 4 or we're at the bottom of number 5. You see 5 goes down to 440. So we're going to use 5 because this one's be maxed out. This one here we got plenty of room to work with. So you want number 5 fingers. So you have to look over here to see what numbers are over here. Is that 405? Let me see. That looks like number 4s are in here. Are missing, so that means they're in the machine. So number 5 is what we need. So we're going to swap out the fingers. See, the fingers are tapered on one side. That's on the inside, and they're radius to ball shaped here on the outside where they go against the cylinder bore. That's how they work. And I actually got them individually color coded because it matters which one goes in which hole. Even though it's not supposed to, it does. And this tells you how to use your mic and a bunch of other crap. These are all the sharpening things in here for sharpening up your stones, which are cutters, which are carbide right here. And there's a lapping plate over here on top of the motor that you lap in the carbide with. So the machine is self-contained, has all the stuff you need to do jobs. So this is for doing like car blocks where you pull it in from the bottom of the cylinder decks. You bolt this thing on top of your block, and you bore the hole next to it. This is our safety device that goes up here. It doesn't work because when we bought the belts didn't work. So I had to make an oversized spacer here, or pulley, to bring it out to big enough. And even though this is a matched set of belts, you can see how the belts are not matched. See, this one's looser than this one. Even though they have the same numbers on it. Wonderful. So just because you buy parts that are supposed to be correct, doesn't mean they work. So you make them work. Okay, so I'm going to change out these cutters down here. They come out of the holes right here. There's the first one. That would be the unmarked one. This would be the black one, I think. That's 2. That's 3. And this one over here was number 1. So 1 is one color. Black is the number 2 color. See, I got black on the red, my 3. That's how I color code them. That is not factory. That's how I do it, though. It seems to help. The better you can keep your accuracy, the better. Okay, so this is number 3, number 2, and number 1. 3, 2, and 1. Okay, this is number 3. It's over here. So number 2. 2 is over here where it says 2 next to it. And this should be number 1. Okay. Well, this handle up here is what adjusts the ram going inside. There's a big tapered pin that goes all the way down and pushes the pins out down here. Okay, we're all the way down, so that expands it up a little bit. You make sure they're in with your fingers on the bottom down here. Make sure they're all compressed in so you don't hit anything. Get the crap out of the way so I can put my foot down here. Somebody left some junk ass cylinders in the way. I don't know who would do that. Yeah, I can get in here now. I bet you. Just crank this thing on down. When you get close, you stop. So there's the fingers coming down. You got to stop because we're not centered. So now you have to center the boring bar over the hole. And drop it some more until it goes in. There, it went in. Go down a little ways. That's far enough. Now, the bad spot's over on this side over here, so I'll move this thing over to here. And we'll put my feeler gauge right on this side. And that's going to shove the boring bar that way, because that's the bad part of the cylinder over there. So I'm just going to stick this in there. And we're going to tighten it up and make an initial cut and see what happens. Go. Make sure it's in there. A little clamp pressure, but not real heavy. Doesn't take a lot. If you force it, you just break things. Pull that back out. Make sure you had 5 and not some other number. You do. And you pull it out, or you can use power. Crank this thing all the way back out. The pins don't go in very far because we're on the smallest size already. Okay, and we get to set our mic. So we should be around 80, I think was our number we were on. So this is a mic right here. So 3.5. Let's see, where's 3.5 at? Damn, light's killing me over here. Okay, there's 3.5 inches. We bring her down 20. That should be 80 right there. Okay, so we should be on 20 thou under the 3.5 inch, which is what we want. Now this only goes to a certain small size, and I don't know if that'll fit in here or not. It should. Find out. Make sure you hold it in so you don't bounce into it. Yep, get a little extra. Rotate to make sure it's clear. And this here pinches the cutter in. A little pressure, not too much. Pull that out. Now your boring bar is set. So we just set our cutter right here to diameter that should just barely cut on this side and not on this side. Assuming everything is put in there correctly. I I have been known to screw up. Usually when you screw up, it's one turn, 50 thousandths. So if you're off by 50 thousandths, it causes a lot of damage. Pretty much junks whatever you're doing. Okay. Back here, the transmission, got high gear and low gear. That's low. That's high. Let's put it back to low. Let it power down a little bit. This is the power feed right here. So it's just barely hitting. That's enough of the pump. Gotta push the reverse button there. Okay, so it's taking a really heavy cut right there. And it's not even cutting anything on that side. So I think we already are way over what we wanted to be. That's a pretty heavy cut. At least it looks heavy. Where's our mic at? Okay, put this at, we're 90 we were going for. Okay, there's 0, 95, 90. Yeah, it takes 2 hands to do that. There we go. I can't read the numbers, it's too far down. The problem with that setup, what we're doing. Alright, so we're going to come back here and we'll take the mic and measure the caliper, because I can't read the number. See where we're at here. Okay, we're about 84 thousandths. That's where we're at right now. We're going to clean at 92 or something. The problem is we're only cutting in part of the cylinder, not all of it. So we're over too far, I think, right now. But we don't know because we don't know how deep the cut is on the bottom. So, usually what I do is I just, we can take a cut, which will make it kind of oval shape. And if we think it'll clean, I can recenter it and pull it back to cut in the center of those 2 cuts. And we probably have enough to hone with, maybe. Or I can pull it back a little bit, see if it'll come over this way a little bit further, check it, and then we can always cut extra if we want to. So, this one here. I'm feeling my fingernail, which one feels about, they feel about the equal depth right now. So we moved it over 5 thou. So, I think what we're going to do is we're going to pull it back a little bit, I think. And we'll just pound it through. Then my flashlight. Yeah, I had a flashlight with me earlier. I lost it. See, everything's a guessing game. You either go for it or don't go for it. Okay, I'm going to look at my grooves. Groovy. It looks pretty groovy. I'm just going to pound it through. I'm going to go with my original assumption and go for it. Okay, let's go. I have a depth stopper right here that I haven't set yet. We're going to go down this far before it shuts off. It's been too long since I remember what all these numbers are for, so we'll just continue. Lights on. You can hear I quit cutting heavy already. You can see the edge of the cut over there, straight up and down, which is what you want to see. Straight up and down the line. If it's cut at an angle like this, that means your cylinder is cut in the sideways. If you see a vertical line, that means we're cutting down the whole side evenly. This is what you want to see, obviously. And there's all the chips down there. I'm making chips right on there. If you don't shut off before you hit the bottom of the table, it breaks something inside the transmission. I've done that before. It gets expensive. Breaks gears. Screws things out. That's why it makes a little bit of noise when it runs right now. Then there might not be any oil in it. That's the other thing that happens. Before it stops, so that's about an inch and a quarter. You'll see the head pop out at the bottom about 3/8 of an inch before the cutter comes all the way out. I don't even see it yet. I still got that much more to go up there. Getting close to it's going to bottom out. Seeing nothing yet, so that means we're going to have to speed that up a little bit. There's a red right there, maybe that's what it's supposed to be. We'll see. Not enough. So we just stop. And we have the cutter there, and it's just coming out the bottom. Alright, close enough for now. Okay. Alright, we need to go a little bit further. There's a line right there, let's go with that. Okay, so what happened here? It looks like we cut all of the bad area out, and the cylinder's a little bit of wear to it. You can see how we were going in straight, and then all of a sudden the cylinder went sideways. That's from wear. So, but you can see almost all the marks out down there toward the bottom. You can see, I don't know if I get up here when it's high enough. There they are. See those marks right there? So it didn't clean all the way through just yet. Those look like they're pretty light, but I can't get my hand in there to tell. Too far down. But you can see how we got half the cylinder. We're not even cleaning on over here yet. So I'm going to go ahead and recenter the cylinder, I think. And then we're going to have to cut more. Alright. Like I said, I don't think this piston is going to clean that we're shooting for right now. Center over here. We still want to cut more on this side, so I'm going to put the third leg this way and the two small ones here. This would be the lowest side, so it'll cut more here before that side comes in. You have to just look at how things work. There we go. Just go down a little bit. Recenter. I'm really talking like we're moving, you know, a couple thousandths, 3 thousandths at most, probably a couple. all you're moving it, not much. But it matters. Okay. Okay, so now go ahead and give it. So I'm going to clean it 90. Let's see, I don't know what we got to work with. I think it's going to go all the way. We'll go right to 89, which is our number, our max number. I can't tell what the bore is going to be because I can't measure a bore yet. A certain size it's on the money, other size is up to a thou off. Usually it's within half a thou, but you never know. The way you sharpen the cutter makes a difference on how it bores. Sometimes it bores under, sometimes over. Okay. And we're off to the races. Helps to hit the button. I thought I did. Cutting around. You can hear the uneven bore, but it's cutting all the way around the whole circle. You can hear it. Can't really see the line on this side. You can see the mark on this other side though. I don't think that's going to be enough between those two gouges out on the bottom. Basically, it's just making the cylinder round at this point. You can hear it cutting around, that's what you want to hear. A little bit of an offsetting you can hear, but it's pretty round. See the vapors coming up? That is the hazardous material you're not supposed to be breathing. As soon as I put this in front of it, I keep the air from getting in my nostrils. We're going to go down until that bottoms out right here. That's how much far we've got to go. Hold the bore up. Bore is clean everywhere I can see. And we do have a round hole now. As much as we can tell. No big heavy clunk noises yet. That's a good sign. Those are not the noises you want to hear. Clunking is never a good sign. Getting there. Cleaning up the cylinder while we're doing all this. Just came out the bottom. Oh, it cleaned. Amazing. Alright, that looks nice. Jeez, every time you get surprised, you never know. Nice round bore. Those marks down there that were way the hell down there are not there no more. See? That's always a plus. Cylinder appears to be round and cut all the way around. Nice and even. Now it comes down to what size it is actually cut. Can we use it, or do we have to bore it bigger? That is the question. So that's what the mic's for. Okay, so we're going to set this thing for our number we want. 0. Theoretically we should be at 89, which would be 14 on the mic. It'll probably clean at 15. There's 15. This should have drag on it. Ooh, it's got a lot of drag. Good deal. Where's my number? There it is. I'll move it down to 14. That's what I actually set it for. And that's tight too. Oh, it's cutting undersize. Alright. Cut down, we'll go down to 13. Yep, that went through. So it looks like we cut half a thou undersize. Yep. Check the other side over here. Yep. Okay, so it's cutting a half a thou under. We gave an extra thou to work with. See, we're at 14.5 right now. 15 is what we were shooting for, but I'm good with that. So I'm happy with that. At least I think that was the number we wanted. Maybe we should double check. Yeah, we'll do that. Okay, so we saved it with a small bore. We only had a little over 15 thou to work with right there. Probably about 15 thou is all we had to work with to clean the cylinder. We still got 3 more to hone out to get, you know, the full 20 over. And it was worn, so we probably didn't have 15. We probably had like 13.5, 14 thousandths. But we cleaned it. It does look deep, but they weren't that deep. So there you go. Okay, now we're going to have to put a chamfer on top of the cylinder. So I have a bit here that has a 45 on the top. So I come down, I kiss the top of the cylinder, and that allows you to put the rings in a lot easier. Rings like have a nice chamfer to go in, not just a straight sharp edge to break everything. Clean this out here. Okay, this I just eyeball it. It doesn't have to be perfect. It just has to be on the cylinder. There's a range that will work. As long as you're on the range, you should be good. 2.4. About 30 thou. That looks good. Okay, so there's our bit right there. Whoop. So we're right there on the edge of the cylinder right there. Of course, it's right there's where you want to look at over here. So you can see how it overhangs just a little bit on the edge. Whoop. So it's not quite to the outside of the cylinder, pretty close. We don't want to cut all the way to the outside anyway. Okay, well, you make sure you sweep it around, make sure it doesn't hit anything. It does. The power, the speed, and this hand's right, we'll bring it down hand. So we hear it hit, right there it's hitting. It's good right there to hand. Find a spot where you can see a chamfer, as you can see over here. So now it has a chamfer right back in there. What I look at the top margin of the cylinder, that's the flat part of the cylinder. You can kind of see it over here. I was watching it cut back onto that. So that's how much you do it. And there's my interruption. Okay, I'm going to get this out of here. We'll be back.